We shall see questions on Newton's backward interpolation formula. So the question is, apply Newton's backward interpolation formula to find y of 3 given the data. So here again x and y values are given. X values are -4, -2, 0, 2, 4. Remember, for Newton's forward or backward interpolation formula, x values need to be equally spaced. Here x values are clearly equally spaced. Spacing between adjacent x values is 2. -2 minus of -4 plus 4 gives 2. 0 minus of -2, 0 plus 2 is 2. 2 minus 0, to find the spacing between adjacent x values, just calculate the succeeding minus preceding value. 2 minus 0 will be 2. Then 4 minus 2 is equal to 2. So all these x values are equally spaced. Spacing between adjacent x values is 2. So h will be equal to 2. First construct the backward difference table or construct the table of differences. First two columns are x and y values, then the succeeding columns are nothing but the differences. So here the third column will be first order difference, or here we can also call it as a first order backward difference, denoted as a del y. Then the succeeding columns are second order difference del square y, third order difference del cube y, fourth order difference, fourth order backward difference del power 4y. So again, to construction of the difference table is as before. You have to go for succeeding value minus preceding value of the previous column. So to calculate the entries of the third column, you look at the entries of the second column. In the second column, you calculate succeeding value minus preceding value. 1 minus of -25, 1 plus 25 is 26. 3 minus 1 is 2. 29 minus 3 is 26. 127 minus 29 is 98. So these are the entries values of first differences, or here you can take it as first order backward differences. Then the second order differences. In the fourth column, to calculate the entries, you look at the entries of the preceding or third column. From the entries of the third column, you have to calculate succeeding value minus preceding value. 2 minus 26 is minus 24. 26 minus 2 is 24. 98 minus 26 is 72. So these are the entries or values of second order backward differences or second order differences. Then third order differences or third order backward difference. To calculate the third order backward difference, you see the column, preceding column, which gives the entries values of second order backward difference. From that, you calculate succeeding value minus preceding value. 24 minus of minus plus 24 gives 48. Then 72 minus 24. 72 minus 24 gives 48. These are the third order differences or third order backward difference. Then the fourth order backward difference, look at the preceding column. From the preceding column, you calculate succeeding value minus a preceding value, that is 48 minus 48 or equal to 0. So which gives the entries of fourth order backward difference. So in the table we have the values up to fourth order backward difference, but in the formula you need not consider the term containing fourth order backward difference, since the value of the fourth order backward difference is 0. In the formula you can consider up to the term containing third order backward difference. Now for backward difference table, for backward difference formula, from the table we take only those values which are at the bottom of the column. means last entries of each column. So last entry of y is taken as yn, then del yn, del square yn, del cube yn. So here yn is 127, del yn is 98, del square yn is 72, del cube yn is 48. Write the formula, the Newton's backward difference interpolation formula y, which will be yn plus p into del yn plus p into p plus 1 by 2 factorial into del square yn plus p into p plus 1 into p plus 2 divided by 3 factorial into del cube yn. You need not consider the term containing del power 4 yn since the value of that is 0. You can use the letter P, or you can write the formula by using the letter R. P or R, doesn't make any difference. So P or R will be equal to x minus xn divided by h. X means that value, that x value at which y is to be calculated, 3. Then xn means last x value, which is 4. H means the spacing between adjacent x values, which is 2. So x minus xn divided by h or equal to 3 minus 4 divided by 2 minus 1 by 2 or minus 0.5. Now put p as minus 0.5 and all the other values of backward differences. You get the value of y, which is equal to 66. Similarly, if we go for the next question, estimate f of 7.5 from the table. X values are 1, 2, 3, 4, 5, 6, 7, 8. Corresponding function y values or f of x values are also given. You can see from the question, x values are equally spaced. Spacing between adjacent x values is equal to 1. So h will be equal to 1. You are asked to calculate y at 7.5, and 7.5 comes somewhere at the end of the table. So to calculate f at 7.5, we'll use Newton's backward interpolation formula. So to use that backward interpolation formula, first we need to construct the backward difference table or the difference table. As before, first two columns are x and y values. Then the succeeding columns are the columns which gives the differences of different order. So third column, first order difference. Look at the second column, go for succeeding value minus preceding value. So it is 8 minus 1, which is 7. Then 27 minus 8, which is 19. Then it is 64 minus 27, which is 37. 125 minus 64, which is 61. Succeeding value minus preceding value. This is what you have to calculate. 216 minus 125, which is 91. Then 343 minus 216, 127. 512 minus 343, which is 169. These are the entries values of first order backward difference. Then second order differences or second order backward difference, also denoted as del square y. So to calculate that second order differences, you look at the entries of the first order differences. In that you calculate succeeding value minus preceding values. So 19 minus 7, 12. 37 minus 19, 18. 61 minus 37, 24. 91 minus 61, 30. 127 minus 91, 36. 169 minus 127, 42. So these values gives the values of second order backward differences or del square y. Then the entries of the next column, third order differences, third order backward differences. 18 minus 12, which is equal to 6. 24 minus 18, which is equal to 6. 30 minus 24, which is equal to 6. 36 minus 24, which is equal to 6. 42 minus 36, which is equal to 6. So all the entries of this third order backward differences are equal, same, which are equal to 6. Then the succeeding column, in the succeeding column, all the entries will be zeros. This is because in the third order backward difference column, all entries are same 6. So when you go for a succeeding value minus preceding value, all the differences will be zeros. So since the fourth order and fifth order differences, sixth order differences all are zeros, you need not consider or you need not write that columns. In a column, suppose if we get all the entries as same end values, then you need not write the succeeding columns. You can stop with that. Here in the table, third order differences are same. So actually you can stop with this. You need not write the remaining two columns or remaining any number of columns. So in the formula, you can use the formula up to the term containing third order backward difference. So in the formula, we will be using the values which come at the bottom of these columns. So last y value is yn 512, del yn 169, del square yn 42. Del cube yn, which is a 6. It is enough if we use the formula up to the term containing del cube yn. So the formula for y or f of x will be yn plus p into del yn plus p into p plus 1 by 2 factorial into del square yn plus p into p plus 1 into p plus 2 divided by 3 factorial into del square yn. P means x minus xn divided by h. X means that value at which y value is to be calculated, which is 7.5. Then xn means last x value, which is 8. And h means the spacing between adjacent x values, which is equal to 1. So 7.5 minus 8 divided by 1 or equal to minus 0.5. With these values, if we substitute all these values along with the values of backward differences in the formula, you get the value of f of x at x is equal to 7.5 as equal to 421.87.